All right, so a little bit of review. Our stationary points, that's where your tangent is horizontal. So the idea that something is changing direction, you go from an increasing function to a decreasing function, and your tangent is 0. Your slope of your tangent is 0. That means that the derivative is 0. So here's a diagram that says 3 basic types. You've got your maximums and your minimums. And you can draw an x cubed graph for the third type. That would be right here at 0, 0 on an x cubed graph. It flattens out enough so that your tangent is equal to 0, even though it's not a maximum or a minimum. And we're going to see what that looks like when we take our derivatives and look at how the function is increasing. Then it has a stationary point, and then it would be increasing after it as well. So we have a local maximum when it's increasing before and decreasing after, and a local minimum when it's decreasing before and increasing afterwards. And we've talked about local minimums and local maximums, and then there's also absolute minimums and absolute maximums. So that's the difference between a relative extrema and a global or absolute one. So there's a picture of something like an x cubed graph where you have a stationary point in the middle. Okay, so all this leads to what we're going to be doing for helping us graph things is the first derivative test. So we can find our maximums and our minimums. We've already done this a little bit. But what we're going to do is we're going to take our derivative. We're going to find our critical numbers, and then find out if they are minimums or maximums. So one, you're going to know if you have a maximum. And this is going to be easy because this is all based on our number line thing that we've done before. And you find a critical point. Say it happens at the number 2. You plug in something before 2, you find out that the derivative is positive, telling you that your function is increasing. Then after 2, you plug in a number into your derivative and find out that the slopes are negative, which tells us that it's decreasing. And then we would know that at 2, we have a maximum, a local maximum, because it's changing from positive to negative. And we'd have a local minimum. Say you had another value at 3. Before it's negative, which means your function is going down. After it's positive means your function is going up. So the only way that can happen is if you have a local minimum at that point, and there it's changing from negative to positive. So if it's changing from an increasing function to a decreasing function, makes sense that you'd have a maximum. And if it's changing from a decreasing to an increasing, that makes sense that you'd have a minimum.